Now that we've learned how to solve a linear equation, let's move on to talk about systems of linear equations. On test day, you're often going to be asked to solve for more than one variable. When this happens, you're going to need at least as many equations as there are variables in order to get numerical solutions for the variables. Now, there are going to be two ways to solve for variables. The first is combination, which is going to involve adding or subtracting one equation from another in order to cancel out one variable. The second method is substitution. This involves isolating one variable using one equation and then plugging that expression into the other equation. We're going to get a chance to practice both methods. Let's start with an example. The first example says solve for x and y if 10x minus 3y equals 10 and 5x plus 6y is equal to 15. Now there's going to be situations in which it's going to be more efficient to use one method over the other. For this example, we're going to use combination. The goal of combination is to line up your equations and either add or subtract them with the intent that one of your variables is going to drop out. Before we can do that, we're going to need to multiply the first equation by something in order to be able to eliminate y. Take a look at your y terms. In our first equation, we have -3. In our second equation, we have +6. In order to be able to eliminate those y terms, we're going to need to multiply our first equation by 2. So when we multiply our first equation by 2, we get 2 times the quantity of 10x minus 3y equals 10, which is going to equal 20x minus 6y equals 20. Note that we haven't changed the equation at all. What we've done is created an equivalent equation in a different format that's going to be easier for us to work with. Now, let's line up the two equations. 20x minus 6y equals 20 above 5x plus 6y equals 15. Now that they're lined up, we can add like terms. 20x plus 5x equals 25x. The y terms drop out because -6y plus 6y equals 0. And on the right-hand side of the equal sign, we have 20 plus 15, which equals 35. Right now, we have reduced our system of equations to one equation with only one variable. So we can move ahead and solve by isolating x. Divide both sides of the equation by 25, which gives us x is equal to 35 over 25, which reduces to 7 over 5. Now that we have a numerical solution for x, we can plug that value into either of our equations in order to get a numerical solution for y. Let's plug it into the second equation. Substituting x is equal to 7 over 5 gives us 5 times 7 over 5 plus 6y equals 15. When we multiply that through, we get 7 plus 6y equals 15. Subtract a 7 from both sides of the equation gives us 6y equals 8. And then divide both sides by 6 to get y is equal to 8 over 6 or 4 over 3. Now that you've seen how combination works, let's try an example that's going to illustrate how the substitution method works. The example reads, find the values of m and n if m equals 4n plus 2 and 3m plus 2n equals 16. Using substitution, we're going to solve one of these equations for one variable in terms of the other, and then substitute that expression into the second equation to solve. Now notice, in our two equations, we already have one equation solved for a variable, the first one, m equals 4n plus 2. Since we already have that equation solved for m, let's use that expression and plug it into our second equation. Plugging it in, we get 3 times the quantity of 4n plus 2 plus 2n equals 16. Let's distribute our 3 to get 12n plus 6 plus 2n equals 16. Now we can combine our like terms. 12n plus 2n equals 14n. Subtract 6 from both sides to equal 10. Now we have 14n equals 10. In order to solve for n, we need to divide both sides of the equation by 14, giving us n is equal to 10 over 14, which reduces to 5 over 7. And we're not finished quite yet. We need to solve for m as well. Take the value of n, 5 over 7, and plug it into the first equation in order to solve for m. So plugging that number in, we get m equals 4 times 5 over 7 plus 2. Multiply 4 times 5 over 7 to get 20 over 7 plus 2. And then we're going to need to change 2 so that it has a common denominator with the first fraction. 2 can be converted to 14 over 7. So our final step is to add the numerators of our fractions. 20 plus 14 is 34. So our answer for m is 34 over 7. Now that we've illustrated both of the methods for isolating a variable and solving a system of equations, I'm going to give you some time to try some variable exercises on your own. Once you're finished, we'll put up the answers and go through a few examples together. Okay, put down your pencils. Now you can check your answers. Now let's take a look at example number 1. Now let's take a look at example number 1. Here we have a system of equations, x plus y equals 2 and x minus y equals 4. Taking a look at those two equations, let's decide which method is going to be most efficient. What you should notice is that your y terms are going to cancel if we add our two equations. So let's use the combination method. When we add our x terms, we get x plus x equals 2x, y plus negative y equals 0, so those cancel out. And then on the other side of the equal sign, we have 2 plus 4, which equals 6. Now our equation reads 2x equals 6. We've reduced it to one equation with one variable. Divide both sides by 2 to get our answer, x equals 3. Now we can use that value for x to find the value of y. Plug in x equals 3 into the first equation. We get 3 plus y equals 2. Solve for y by subtracting 3 from both sides. Y is going to equal negative 1. Using combination can save you a lot of time on test day. So when you're looking at a system of equations, look to see if one of the variables is going to easily drop out. That's going to tell you to use combination. Okay, now that we've tried those examples together, let's go ahead and take a look at a test question. Number 6 says if 2x plus y equals negative 8 and negative 4x plus 2y equals 16, what is the value of y? When you take a look at both of these equations, you'll notice that we could multiply the first equation by a factor of 2, which would allow us to add our equations and get one of the variables to drop out. So let's start there. Multiply the first equation by 2. When we do that, we get 4x plus 2y equals negative 16. Now line up that equation with the other equation that we're given. When you add the like terms, we have 4x plus negative 4x, which is equal to 0, so your x terms will drop out. Moving over, we have 2y plus 2y, which is equal to 4y. And on the other side of the equal sign, we have negative 16 plus 16, which is equal to 0. Our equation now reads 4y is equal to 0. We've reduced the system to one equation with one variable. In order to solve for y, we divide both sides of the equation by 4, leaving us with y is equal to 0. Now let's go back to the question. It asks us, what is the value of y? We found the value of y. So we're done. We don't need to plug that value in and get a value for x, because that's not what the question's asking us to do. The correct answer here is answer choice C, 0.